Now let's study some property for the definite integral. When the limit is the same, the answer is 0. It's obvious, right? Because the formula integral from a to b of f of x dx, you compute the antiderivative and evaluate b and evaluate a, no? So you suppose that a and b is the same, subtraction is 0. When the limit interchange, it's obvious that so you interchange the limit. The answer is the same but the opposite sign, minus here at the front. There's another property. Suppose you have one intermediate value cn between a and b. We can separate the integral in two pieces if you want, not necessary, depending on the problem. Let's go directly to example now. Okay, we compute the antiderivative. Antiderivative 2x is x squared divided by 2, and the 2 is cancelled, stay only x squared, and antiderivative e to the x and e to the x. Evaluate in between -1 and 0. You evaluate 0 first, get the upper. Entonces, I recommend put the parentheses 0 squared minus e to the 0 minus another parenthesis -1 squared minus e to the -1. Okay, this is 0, this is 1. This is -1 squared positive 1. Sorry, this is e to the 0 is 1, but we have a minus here in the front, no? This -1 is this. The -1 squared is positive 1, but we have a minus in the front, it's minus e, and double negative become positive, e to the -1. So -1 and -1 is -2, plus 1 over e, if you want to eliminate the negative exponent, and that's it, that's the answer. Okay, the example 2 is super easy because the antiderivative of the secant square is tangent. Entonces es tangent of x. Evaluate in between 0 and pi over 4. Remember, upper limit first. Tangent pi over 4 minus tangent 0. Tangent pi over 4 is 1, tangent 0 is 0, and the answer is just 1. Okay, this is a little bit more complicated. I recommend do some algebra first. So I copy the integrand function along. Okay. I separate into pieces. 1 over radical x plus cubic root of x divided by square root x. You express this using a fraction exponent. This is half. This is 1/3, and this is 1/2. So using negative exponent, this is x to the -1/2 plus now 1/3 minus 1/2. LCD is 6. This is 2 minus 3. This is -1/6. X to the -1/6. So my problem now is integral from 1 to 64 of x raised to the -1/2 plus x raised to the -1/6 dx. Okay? Okay. Let's do the antiderivative one by one. The antiderivative, okay, suppose I need to compute this 1 to 64 x to the -1/2 dx. Okay, antiderivative is power rule. You add in 1. -1/2 plus 1 is +1/2. divided by half, que es the same of multiplication by 2. Evaluate n between 1 and 64. So we're doing that part only. Entonces 2 is a common factor. This is 64 raised to the half minus 1 raised to the half. This is 2. 64 raised to the half is equivalent to, say, square root of 64, que es 8. 8 minus 1 is 7. 2 times 7, 14. Now integral from 1 to 64 of the x to the minus 1 over 6 dx. Okay, this is power rule again. You add 1. Negative 1 over 6 plus 1 is 5 over 6. Divided by 5 over 6 is the reciprocal is 6 over 5. Evaluating between 1 and 64. So 6 over 5 is a common factor. We have 64 raised to the 5 over 6 minus 1 raised to the 5 over 6. Okay. This is relatively easy because this is equivalent to, say, 6 root 64 raised to the 5th power. And 6 root of the 64 is 2. And 2 to the 5th power is 32. This is 32. 6 over 5 is 32 minus 1 is 33. So 6 times 33 over 5. The answer is 186 divided by 5. This is what the final answer. One of the final answers then put together is 14 plus 186 over 5. You find the least common denominator, 5. 5 times 14 is 70, plus 186 is 256 over 5. When you add this and this together, final answer.